This is a continuation of Jacob's Chapter 11, Problem 16, Wally's Widget Warehouse. It's open 12 hours a day. There's 3 internal processes here. The upstream process runs quickly at 100 customers per hour. So over this 12-hour day, it can produce 1,200 orders. The next process runs 20 orders an hour slower. So we're going to have a buildup of a buffer here that eventually this process is going to have to catch up on at the end of the day and work overtime. And the same can be said for the third process here that only operates at 60 customers per hour. This is the bottleneck of the system, and that limits the overall process for the entire system. The throughput rate is limited to 60 customers per hour for the whole system because that's what your bottleneck runs at. So we solved for A and B. Now on to C and D. We want to know what point do we have the maximum number of orders? What is the number of the maximum number of orders at the point when it's at the highest level during the day? And this is for the picked process, for pick. So we're going to go over to our Excel sheet here. And for a moment, I'm going to cover up 3 because we're really answering for the pick process, not the pack process. Okay. So we know that the second group of second workers in the second process here have to work an extra 3 hours to diminish or eliminate the buffering that ended up here. We had an excess work in process that was sitting buffered here until they could process it. So after the 12 hours, there's no more order. There are no more orders coming in from the process 1. And at that point, after 12 hours, at the difference of 20 orders per hour, you end up with 240 orders sitting in the buffer. As soon as the process 1 people leave and stop shoveling more orders at 2, process 2 is able to start eliminating this buffer. So at the rate of 80 per hour, it starts reducing the buffer down till it's 0, and they're able to leave when that buffer is 0. They're able to leave, and that's at the end of the 15th hour. And just graphically here, we can see that the maximum number that's ever sitting in the buffer is 240 for the second process. So they're glad when A leaves, they can start working against just the buffer now. There's no more new ones coming in, and they can diminish that at the rate of 80 per hour. You can see those numbers here, and they have to work for 3 hours and can eliminate them. Very similarly, the work process for the third group here that's working in the third process. Remember now that the second process is still shoveling orders at them for another 3 hours. And there's a difference in processing rate of 20 per hour. So that after 12 hours, that buffer still is increasing. Process 2 is still working fast to get out of there and shoveling these orders back at the process 3. And you'll see at that point, at a difference of 20 orders per hour, 15 hours, multiply them together, you're going to have 300 in the buffer. And then finally some relief comes, and process 3 starts working against that buffer now. Now they're working against now that the stage 2 people, the process 2 people left, no new ones are coming in, and they're just working simply on the buffer. So for part D of the question, the greatest number for the packers will end up at the end of the 15th hour will be 300. That's how big it gets. Those are the 2 answers, 240 and 300 for parts C and D. Now let's take a look at the last part of the question here, which is if we double the packing capacity from 60 to 120 orders per hour. Packing is our problem back here, right? Packing's our problem. It's the weak link. So what we've done is a couple different ways is we can upgrade this unit, this group of people and their equipment. Maybe it's equipment that they need, and you can actually get a new packer in there, another packing machine, and you double the throughput by getting a new packing machine in there. Or possibly you could put one of these in parallel. So you have a new group. You add a whole new group with all the equipment that they need in parallel. And that way, if you feed both of them, each of them is doing 60 per hour times 2 is 120 per hour. That's what we're looking at here. Very common. This is a very common problem in any kind of operation, is to speed things up. How you're going to do it. What impact doing that has on your answers in B, C, and D. Now if you look at it, let's just look at it first. If this is 120 here, it's faster than any upstream process. Basically that means it's going to keep up with and actually exceed the capacity of the upstream. Now the bottleneck is 80 per hour, and you can run at 120. It's significantly faster than the bottleneck. This is going to introduce starving because it's waiting and waiting and waiting while the upstream process is trying to get anything out. Now 80 is being rushed because you're able to process at 120. You'll have unused capacity. You're able to do 120 an hour, and yet you're only going to be getting 80 an hour. So that's only at 2/3. It's 80 over 120 utilization of your groups down here in the pack operation now. So those are a lot of terms coming out in this problem, and worthwhile to actually go through it at this level of details. Still taking probably more words to explain it than to actually do it once you catch on to how some of the math works here or some of the configurations work. So if we double the packing capacity from 60 to 120 orders per hour, what impact does this have on your answers in B, C, and D? So B, how long will the picking and packing operations have to work if we have a day where the order taker works at maximum capacity? Let's go edit the Excel file, which I haven't done yet ahead of time. So we're going to add this in here. Now we're going to do call it a new 3 process. It's pack, but it can operate at 120 orders per hour. Okay. If we look at this now, it's running faster. What we're going to do is say, we're going to use the power of Excel. These equations you just do on paper anyway. Power of Excel to say, excuse me, how many per hour it can handle at 120. It will take 80 per hour from the pick process. So 80 are coming from from upstream here. So it can't do more than 80, so it will do 80. Okay. It'll do in the next hour. It will do the next 80 that the second process gives it. So what you're going to end up having to do here is it's just going to match. See how I'm doing the math here? I'm just saying these cells are going to equal to whatever the middle process can now feed me. See how I'm adding that in there? And what we're going to find is it's waiting around. It's being starved. It can go faster. It's not being utilized as much. And so if you notice, what I did was just make these numbers match these numbers here, okay? Because it can take anything that the upstream process can take now. Okay, so if we go back to the question, it says, how long will the picking and packing operations have to work if we have a day where the order taker works at maximum capacity? Now we can all leave after the 15th hour. See how that works now? I'll colorize that with, let's put some pretty color in there, a little lighter version. Here we go. Okay, so I just wanted to draw attention to the 15th hour. We can leave. We're all done at 1200 here. We no longer have this buffering issue. They're not building up ahead of time. Okay, so that's how you solve B. So it should be 15 hours. In given B, again, that we're running full rate for 12 hours at the input stage, 100 orders per hour, what is the maximum number of orders waiting to be picked? What you're going to find out then, if we put our new buffer here, so this is new buff. Okay, if we put our new buffer there, we'll go orange on it so that it matches. And we'll put this in blue. Some kind of blue with that blue there. Okay. Okay, so this is the new buffer. We're never going to have anything in the buffer because it's working that fast. It's keeping up faster than the second stage can put it out, so these are going to be all 0. Okay, so you're never going to have an issue where there's anything falling into the buffer there at all. Okay. So the maximum number of units in a buffer will come back to this point here, which is 240. That's the greatest number. And that will be the buffer between the first and second stage, because we didn't update these. We only updated the third stage here. And so the buffer here is going to still continue the way that it was. The timing hasn't changed there. So you're going to get 240 is the maximum buffer for the pick stage, and 0 is the number of inventory, if you will, orders. They're never going to have anything in the buffer. So that's how that changed. See, so now we remove the work in progress just sitting there in a buffer between these two stages. Okay, so we solved that. And we have to solve D again. Oh, we just solved everything there. So we just solved all the problems that we needed to show in here. So hopefully that's clear. Any other questions, send them on to me.